Hello, everyone, and welcome to another episode of GDDV 106 Development Concepts. My name is Kasanis. All right, guys, continuing on with week 2. Let's take a look at what we've already done. We have gone through and we have discussed the course as well as did a brief introduction to the Unity interface. In the last episode, we took a look at the idea of object-oriented programming and the creation of classes. And for some of you, maybe that was brand new. I hope it wasn't too confusing. If it was, it's going to become much clearer as we move forward when we start to actually use these ideas inside of Unity. All right, today we're going to continue on with coding, and we're going to work on the idea of the data types that are available within C#. All right, let's get started. Okay, so let's get started with primitive data types. And there are several primitive data types in Unity. But a primitive data type takes one of several forms, and there are several that are available inside of Unity. Integers, floats, doubles, characters, strings, and bools. There's more on the next page, so we'll get to those in a second. Integer. An integer or an int is a positive or negative whole number. A float is a positive or negative floating point number. A double is a positive or negative floating point number that is larger than a float, so it can hold larger values. A character or a char is a single letter or a special character. It's declared in single quotes, and just think of it as like an A or a B or a star or something like that. A string are multiple characters that are declared within double quotes, and you basically put these characters all together to form a string. So like hello world would be a string. Bool is short for Boolean, and it is a true or false value. Additionally, we have enums, vectors, quaternions, and game objects. An enum, or an enumeration, is a set of named constants. So what does that mean? Instead of referring to something as a value, let's say we want to talk about the cardinal directions of the compass, north, south, east, and west. We could somewhere in code say, well, north is equal to 1 and south is equal to 0 and so on, and therefore refer to north, south, east, and west in numerical form as an integer, 1 or 0. 1, 0, 2, 3, I guess. Or if we utilize what's called an enum or an enumeration, rather than referring to the values as a numerical value, we can use a human readable word like north, south, east, or west. And this makes it easier for us to read this particular code. That's what an enumeration is. We'll take a look at an example of it, a practical example, in just a minute. A vector is defined by both a magnitude and a direction. And there's several different types of vectors within Unity. There's a vector 2 and there's vector 3s as an example. A vector 2 is defined by 2 points, an x and a y value, and the vector 3 is defined by an x, y, and z value. Quaternions are super interesting. Quaternions are a mathematical representation of rotation inside of Unity. And I know that most of us are used to utilizing other forms, 30 degrees, 50 degrees, whatever, 9 degrees. We're used to saying things like that. But Unity itself utilizes quaternions. Now, we can convert to our more traditional form of representing rotation into quaternions, but internally, Unity uses quaternions. I am not a quaternion expert. In fact, I find them extremely confusing, in all honesty. You probably have to be a super smart mathematician to be able to fully understand quaternions. But just know that you are able to, through additional code, you are able to convert from a more normally represented form of rotation. Game object. Game objects we discussed a little bit in our last video. And a game object is the base node in Unity, like the base creation within Unity that can be represented within your scene. Creating an empty game object like we did in the last video will create an object that has a name, it has a layer, it has a tag associated with it. It has a transform node that allows us to move it around within 3D space, or rotate it or scale it, etc. And the game object, the base game object, can have additional components added to it to allow it to have additional functionality, to do additional things. We took a look last week at the fact that our camera that we create whenever we created a 2D or a 3D project, Our camera is a game object that has a camera component associated with it, and that's what makes it into a camera. So we can create far more complex objects with the game object, and we're going to be doing that thoroughly throughout this particular course. So primitive data types are not actually variables. So primitive data types are used to declare variables. And we talked about the idea of the class and variables in the last video. You associate variables with a class to define the class itself, to define things that are associated with that particular class. A variable can be defined or declared in the following manner: accessibility, type, and the variable name. So in this example, if I want to declare an integer, I could say int mynum. Now that would declare an integer value, so a negative or positive whole number that we can associate with the idea of mynum, with the variable mynum. Okay? The variables themselves can be, upon declaration, can be defined. The values associated with a variable can be defined or declared upon declaration within the initial declaration. So int mynum equals 8 would automatically create a variable called mynum, an integer value called mynum that has a value of 8 associated with it. Now, I also talked about the idea of accessibility. What does that mean, accessibility? When we declare our variables, they have an accessibility. Variables can be declared as private or public. There are other options as well, serialized field or hidden inspector. We'll talk about more about that later on. But for now, let's just consider the fact that we can declare a variable as private or public. The good thing about a public variable is that it is visible and editable within the inspector. So at runtime, when you start to run your game, if you take a look at the class that the variable is associated with it, if you declare it as a public variable, that public variable will be visible inside of the inspector, and you can change its value. So before, if I had said public int mynum equals 8, upon running my program, looking at that particular class inside of that particular object inside of the inspector, I would be able to see all of the public variables that were declared. I would be able to see my number, and then I'd be able to go ahead and change it from a value of 8 to anything else I wanted. Now, a private variable, it does not show up inside of the inspector. It is set within your code, and it is hidden from the inspector itself. The great thing about a private variable is that it's protected, that other functions or other classes can't access a private variable unless they have some type of access or function that allows them to go in and manipulate that function or read that function in some way. Otherwise, it is not visible outside of the class that it is in. If you declare something as public, however, the public variable can be accessed by external scripts. And that makes it less protected. It's less protected, which means that other things could change that value without you knowing about it. A couple more things that I think are going to be important before we actually move on to a practical example. The variables can be initialized at declaration. So as I've already demonstrated, we could say int mynum equals 8, declaring mynum with a value of 8, but mynum later on within the script can be changed. So later on I can say mynum equals 7, or mynum equals 5, or mynum equals -10, whatever it is I want to set my num to, I can do so later on in the script. Information can be sent to the console through the use of either print or debug log. This is going to become important later on, and I have to talk about this now just so that we can see the output of the scripts that we're going to write in the practical example. Print and debug log will both send information to the console tab of Unity. So let's say we wanted to see mynum and what it equals at any particular time. We could say print mynum, and it would actually print out the value of mynum. We could then manipulate mynum, so mynum equals 10, and then say print mynum, and it would say 10 at that point. So it's all going to be printed to the console. There is no functional difference between print and debug.log. I forget, one uses the other. So either debug log actually uses the print statement, or print statement actually uses debug log. I can't remember which way it goes, but there's no real functional difference between these two. Both of these commands will send information to the console for you to view later on. You can actually format utilizing special characters. So you can format a string utilizing special characters. This is also going to be important. And it's going to be particularly important later on in one of your assignments because I ask you to do this. So guys, if you're in my class, make sure you understand exactly how to use special characters to format a string. So as an example, the /n can be used to format a string. That'll add a hard return into a string. So if I've got, for example, a hello world /n, my name is Kasanis, it's going to say hello world hard return, my name is Casanis. All right, so there's special characters that are available. I will leave it up to you guys to look up the different special characters that can be used in formatting a string. All right, because there's a bunch and I don't want to go over them. I don't want to go over all of them. All right, guys. So I think with that, let's go in and take a look at a practical example of declaring and defining our variables inside of Unity. All right, let's head over to Unity. Okay, guys, so here we are inside of Unity. We've got ourselves our week 2 section here, and inside of our week 2 section, I want to take a look at a couple of things. Right now, I've started a 2D project, and I've got myself my camera. That's all I have, as well as this object called my declaration variables game object. And I'm simply using this particular game object to run the script variable declaration, and we'll take a look at that in 1 second. Before we actually do, however, what I want to do is create myself a brand new game object so you can see how it's done. I'm going to go to the menu and I'm going to say game object and I'm going to say create empty. And in doing so, it automatically creates this empty game object for me. And this empty game object currently is simply called game object. I can highlight the name and I can give this a new name. So let me call this my example game object. Now, what's really important and something that I often forget to do is you have to hit return once you've actually renamed your object. If you don't and you click off of it, the name that you've changed won't be maintained. You'll actually lose that information. So it's really important that you remember to hit return. I always forget. Let's take a look at game object, because the game object itself is one of the data types that we talked about in the little lecture portion. Our game object has a name at the top. It's got something called a tag, and basically a tag is simply an identifier. Unity gives us a number of pre-built tags that we can utilize, but it's really just an identifier. We'll talk about tags more thoroughly later on. We've also got this layer default. It's currently set to default, which is great because if it wasn't set to default and it was a default option, it'd be really confusing. But it's set to default, but we have several other layers that are available to us. And layers, again, is something we'll go over a little bit later on. But layers allow cameras, if you group things within particular layers, you can set cameras to either see layers or not see layers, or have things affect layers or not affect layers, and that kind of stuff. So we'll talk about layers more thoroughly later on. Additionally, with a game object, we have ourselves the ability to enable or disable, so make active or inactive our game object by simply clicking on this little check mark here. So currently it's active, it's available here within the hierarchy. If I turn it off, it is now inactive and it is grayed out. Okay, so we're going to leave it as active. Inactive game objects will not run their scripts, they won't run their update functions, that kind of thing. Okay, so they won't be available. You can turn something on later on. Later on, this interesting thing you can do is you can delay an object from coming into the game, from being loaded into the game by having it start off as being inactive, and then as the game starts, you activate it, and then all of its scripts will run. But we'll talk about that later as well. We're getting ahead of ourselves. Next to that is a little 3D cube-like thing, and this is going to allow you to have a visual component to the game object if you don't actually have a visual component associated with it. Right now, I can see my game object right here inside of my scene, and I can drag it around, right? I'm changing the transform here, the transform node. I can drag it around, but there's nothing here. It's invisible. If I click off of it, I don't know where it is at all. It's gone, right? So this little thing here allows you to set up an icon associated with game objects that don't have a visual component. I can either use one of the ones at the top, so this blue one, this large one here will show me the name. The smaller ones here will not show me the name, but still allow for a visual component to your particular game object. So if you're having a hard time finding them, you can do this. Okay. So below the naming section here is our transform node, and our transform node allows for manipulation of the object in 3D space. I'm currently in the translate tool, and the translate tool, as you can see, will allow me to translate my object. I'm currently translating only within a single plane. I can only see these two axes because I'm in 2D. If I switch out of 2D in 3D space, I can now see the Z axes as well. So I've got all three available to me. Okay, back into 2D, and I lose the Z information, the Z axes. Okay, it's actually pointed directly at my camera. That's why. Okay, if I don't like these values, I can either go in and set them manually. So I'm going to put this to 5. I can do so. I can reset my value to 0, let's say, and in the Z you won't see anything because I'm in 2D. If I want to reset all of the entirety of my transform node, I can go to these three dots and I can choose reset, and it'll automatically reset all the values, my position, my rotation, and my scale. So if you don't want to reset everything, be very careful, because that will reset all of your values. Okay, and that's a game object. That's the game object. If I take a look at this game object that I've previously declared, this game object called declaration of variable game object, I've got a script associated with this particular game object. If I go into my scripts folder, I can see that right here, my variable declaration script. Now, you can either, in creating a new script, I can either right-click like I did before, say create, and create myself a brand new C# script. I can use a little plus sign over here, plus, and say C# script. But if I really wanted to, I could add a brand new script to a particular game object by using the add component. A script is simply a component associated with your particular game object. Just like we looked at before, our main camera has our transform node and has this additional component, this camera component that makes it into the camera. We can add scripts as our components onto our game objects. If I say add component, and let's get rid of the name for now. If I say add component, I can either go down and I can say new script, which will allow me to create a brand new script and add it directly to this particular game object. Or if an existing script is around, so example, array demo, I could go into scripts and I could find array demonstration and add that directly to this as an additional component. Let's say I add it. There's my array demonstration script that I've created, and I can utilize all the functionality there. All right. If I want to remove a component, I can do so with the three little dots. So three little dots, remove component, will automatically remove that particular component. Okay. So right now we've got ourselves our variable declaration script. If I want to, I can double click on the script grayed out section, the script. I can double click and it will automatically open up that particular script inside of our Visual Studio. Okay guys, here we are inside of Visual Studio, and let's take a look at a couple of things that I think are really important moving forward. So just like in the last video, we have ourselves variable declaration as the name of this particular class, and this particular class inherits from mono behavior. Awesome. Now we've got ourselves our braces. I've got a brace here, and then way down at the bottom, I've got another brace right here. These braces are enclosing the class called variable declaration. Everything inside of this is available to this particular class. Okay. A couple things I want to talk about right here. // this is a comment your code for clarity. I think it's important to mention this right away. Many of you have not coded before, so I'm going to say this right away. Comment your code. If I handed this to you right now, you should be able to go through and you should be able to take a look at the comments in my code and understand exactly what's happening. So what is a comment? A comment is a human readable line that is ignored in every way by the compiler. So later on when I compile this, it's going to take out all of my comments. It's going to ignore all the comments, remove them entirely from my code, and only utilize the actual code that's required. So anything that's a comment is removed. It has no effect at all on the actual compilation of your particular script. So for a single line, you can use the // So let's say I come in here and I say // hello. All right, this is a comment, and again, it looks different. It's green. Anything that's green is a comment, and that's because I'm using the dark theme. If yours looks slightly different, that's okay. But your comments will look different. So utilizing the // will allow you to create a single line comment. Let's get rid of it for now. And let's take a look at this next. This is a next group here. This is a multi-line comment, and a multi-line comment is encased between a /* and a // Everything between the /* and the / is a multi-line comment. So we can see right now that I've got a couple of lines in here, and again, they are green. You have to be very careful when you are creating a multi-line comment. Watch what happens when I put in my /*. So let me just remove that for now so you can see. Right now I've got a bunch of code down here. All of this code is actual code that I want to run. As soon as I put in my /*, all of it turns green. Right now the editor is looking for the /*, and when it finds a /*, which is one right here, there's one right here, it assumes that is the end of your multi-line comment. So be very, very careful about creating your multi-line comments and understand exactly how you are creating them and where they begin and they end. All right, if I hit return right now, it's automatically adding a star, and each star is going to be used to identify another line of this particular comment. If I add in my slash at this point in time, you can see that my code is now back. So if I wanted to add a multi-line comment, I absolutely can. All right, and there we go. That's a multi-line comment. To remove it, grab it, highlight it, and hit delete. All right, and there we go. So that is a multi-line comment. Comment your code, guys. If you do so, it's going to become, later on, even your own code, even just for you, later on when you come back, you'll be like, what the heck did I do here? And if you've got it commented, you'll know. Once you start adding a bunch of lines of code, it can get really confusing. Okay, so a couple things I want to talk about. In this particular example, I really just want to take a look at the declaration of variables and the print and debug log. There's other stuff that's occurring within here that we're going to ignore for now. So right away, any variables that are not explicitly declared as public are private. By default, they're private. So I've got myself a public int, my integer, which equals to 10. Because this is public, it is available inside of the inspector. If we look at the inspector, in Unity, if we look at the inspector, we will see my integer 8 as the value. Okay? Float. My float equals 8.8f. Now, the f is extremely important. If we don't have the f, if we take a look at the very next line, double my double equals 8.8. If we don't have the f within the declaration of our float, it will be assumed that this is a double, and it's going to throw an error. Watch what happens. I've declared this as a float, my float. If I remove the f from here, and I click off of it, it's going to say, whoa, 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 red squiggly lines, this is bad. This is actually a double, all right? So the f ensures that we are declaring this as a float value. So make sure you put your f at the end of your float value, okay? Double, my double equals 8.8. These are all, right now, almost everything we've got down here until we get down here, these are all private by default. So double, 8.8. Car, my car equals single quotations, a single quotations. It's important that you're using the single quote options for declaring yourself a character. A string, however, is declared with a double quote. String, my string equals hello world. That's what we should have started with. Hello world in double quotations. Bool. This is the declaration of a Boolean value, and I've declared this without initializing it. Everything above has been initialized immediately. It has not been initialized in this particular point in time. By default, it'll have a value of false automatically. I believe it's default to false. So it'll automatically have a value of false by default if you don't actually declare the initialization right away. An enum. So this is how you declare an enum, and they're a little bit more complicated than what we've done in the past here. Enum weekend days, and then we define what the enum is. So this weekend days is not actually the variable name, it is actually the name of the enumeration that we're creating. So enum weekend days, and inside of my brace and my brace, I've declared the values that are available for the particular enum. Saturday, comma, Sunday. So all of your things, and I can put as many things as I want in there, Saturday, comma, Sunday, separated by a comma. Okay, and then that becomes the values that are available to any enum that you declare later on. I declare a my weekend of type enum weekend days, and I can therefore set my weekend equal to one of the values here. My weekend equals weekend days dot Saturday. I'm declaring it as Saturday. Okay, so that's how you utilize an enum. Declare the enum first, define the values that are available for the enum, and then afterwards you can declare a variable of that type of enum and set it equal to one of the values within the enum. Below that, we have ourselves a declaration of a vector. So this is a vector 2. Vector 3s are done in exactly the same way. Vector 2, my vector 2, and it's slightly different than what we've got above. Here we have equals new vector 2. Now this is really important. So vector 2, my vector 2 equals new vector 2. We're declaring it a value. We're declaring a new vector value, and we're giving it the initialized values here. So vector 2, 0, and 1. This is my x value. This is my y value. So right now, this particular vector 2, called my vector 2, has a magnitude of 1, and it's pointed up directly along the y-axis. That's where it's pointed along. I could declare this as a vector 3 in exactly the same way. Vector 3, my vector 3 equals new vector 3, 0, comma, 1, comma, 0 would once again give me a vector that was pointed up directly along the y-axis. The only difference is we are including the z-axis, the z value within the declaration as well. Okay. Below that, we've got ourselves a public game object, my game object. In this particular case, we have defined it as public, which means it's going to be available inside the inspector. But my game object right now is declared without being initialized. It has a value of null. It has a value of null. So if I try to print this out later on, it's going to say, nope, nothing here, value of null. However, because it's public, I can then set something up inside of the inspector later on. Okay, we've got some other stuff in here which we're going to ignore for now. This is for the next video. We've got ourselves a couple of functions here. We have our awake function, our start function, some other functions that we're going to ignore. Our update function, our fixed update. We're going to ignore all these for now. What we're really interested in is the stuff I just showed you. Let's take a look at the start. So just know that the awake runs before the start. So the awake will run, then our start function. That's all we really care about right now. Inside of our start function, we've got a number of different things. We're really exploring the idea of setting values to our variables here and utilizing the print and the debug. Okay, so this is the start of the start function. Okay, that's going to be printed to our console. Bool equals true. All I'm doing here is setting my bool value, which I hadn't declared previously, I hadn't initialized previously. I'm setting it equal to true. My integer, I'm changing the value of my integer. So in the past, at the top, we said my integer is equal to 8. Down here, I'm saying my integer is equal to my integer minus 5. Well, it's going to have a value of 3, right? It should have a value of 3. So I am changing the value of my integer. It is utilizing the variable here, my integer. It's using that variable as 8, minusing 5, and setting it back equal to the original integer value. So my integer now becomes a value of 3. Okay. We could also change this value in the inspector later on, but we'll take a look at that. And what we will see, actually what we'll see in the inspector though, we'll see that my integer has a value of 3 later on. Okay. Okay, and this is just an example of my print and my debug. Okay, so print my bool is equal to, and now I'm saying plus my bool. So what I'm doing here is I'm concatenating these strings. And what you can see here, my bool is blank plus my bool. So what it's going to do, it's going to print my bool, space, and then the value of true. Print my integer is, space, equals, plus my integer. It's going to automatically change this into a string. My integer value will be automatically changed. It should say the value of 3 here when it prints it out, my integer. Okay. Below this is our debug. This is the example of our debug right here. And this is something we'll take a look at later. Debug.log myString. MyString said hello world. That's what it said previously. So I'm printing out hello world, and then I'm printing out the game object. My game object currently is null, so it's undefined. It won't actually print the game object there. It'll say null. Okay. Then down here I'm saying, print myString plus, and this is an example of the use of formatting, so utilizing our special characters. Print myString plus quotations \n, it's space quotations my weekend. What we're going to be doing here is we're going to be setting this up to allow us to concatenate these different sections of the string, and it's going to automatically add in this special character right here. So it should print my string, which was hello world, so it's going to print hello world in the debug, hello world plus, it's going to hit a hard return, it's space my weekend, and my weekend was set to the value of Saturday. So that's what I'm expecting to see right now inside of our actual running game. I'm going to file, save this, so I can either save all of it or just save the appropriate one. I haven't made any changes, but we can. So I'm going to now minimize this, and I'm going to head over here. Let me clear this out. Clear. And let's hit play. All right, let's hit play and see what's going to happen. So first of all, right now with my declaration of variable selected, I can see that my integer is equal to 15 for some reason. I don't remember setting that. Interesting. Let's set it equal to a value of, well, I should say 8 later on. Well, we'll set it to 8 for now. We can set it to anything we want, all right? So, oh, sorry. I want to show you this. This is what I want to show you. I remember now why it said 15 here. 15. The reason why it said 15 here is I wanted to show you that we will override the value of our declared value, our initialized value. So originally I said my integer was equal to 8, right? And then I said minus 5. So I said you would expect to see a value of 3. However, if I put a value in here, my integer, this value that I put in here in this publicly declared value is going to override my initialized value in my script. It's going to read this afterwards. It's going to say integer is 8. Come in here and say, okay, no, integer is actually 15. And instead of actually seeing the value of 3 like I suggested you'd see, we're going to see my integer is equal to 10. So 15 minus 5 is equal to 10. Game object is undeclared at this point in time. We'll take a look at that in 1 second. Okay, watch what happens right now when I hit play. There we go, play. This is the start of the awake function. We started off by printing that. This is the start of the start function. This is the stuff we're interested in. We printed out my bool is equal to true. And as I mentioned, my integer is 10. It was set to 15. Minus 5 is now 10. And we can see that update right here inside of this my integer value in our variable declaration of our script in the inspector. If we go down, we can see hello world, and we can see a value of null. This null is actually the game object. We have no game object defined, and therefore it's giving us a value of null, right? We haven't defined anything inside of our inspector, and we did not define a value of our game object inside of the script itself. So therefore it's saying, I don't know what this is. It's just null. Okay, this is our debug hello world. This is our print hello world. In our print hello world, we said hello world. We had a hard return. It's Saturday. So this is giving us exactly what we were expecting. If I hit stop right now, you'll note right away that my integer goes back to a value of 15. So it's updating automatically. And if I drag and I drop my example game object into the inspector, right here into my game object, I now have it defined. If I hit play, I can now see everything is exactly the same. My integer is equal to 10, hello world. But now instead of saying, uh-oh, null, it's saying that our example game object is defined as example game object. So my game object is now example game object. Everything else is identical. Okay? If I hit stop here and I change this value to, let's say, 8, and I hit play, we can see that this has been initialized back to 8, and I'm now getting an integer value of 3. Okay, so that is how our declaration of variables works. That is how our initialization of variables works. That is how our print statements and our debug log works, and additionally how our comments worked. I hope that was super helpful for you guys. That's going to take us to the end. I gave you guys a lot. That was a lot, and I think that I may have confused some of you. So if I have, please let me know, guys. Let me know down in the comments if you are following along. Give me a thumbs up. If you didn't follow along, a thumbs down, and let me know what I can change to make it better for you. All right, guys. Thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.